In continue, I want to make some changes in our cluster. So this change will make application access more friendly. So the topic that I want to jump in it now is Ingress. If you remember from the last part, for access to our application, we use something like this one, cluster IP, and the port, for example, 5000 to access our application, or access phpMyAdmin to change anything in database configuration. Also, we need to use cluster IP address and, for example, this port to access phpMyAdmin. So at the moment, maybe these questions comes to your mind, how we can get rid of this one and this one, and just by, for example, this one, just cluster IP /app access to our application, or /phpMyAdmin, it's going directly to phpMyAdmin interface. Also, we can use hostname like this one and this one to access our application and phpMyAdmin separately. Soon, in next some minutes, we will discuss more about which type of ingress we can use for this presentation. Normally, for deployment such access, we need to use reverse proxy. So what is reverse proxy? A reverse proxy is a server that sits in front of the web servers. For example, this is our web servers, and this is a reverse proxy. This is web 1, web 2, and web 3. And for example, the web 1 is running on port 5000, this one running on port 8091, and this one running on port 3000. So by running a reverse proxy, instead of just typing an IP and port number to access the servers, just typing IP address of reverse proxy, and for example /app1, it goes to this one. And if we change the extension to app2, it will go to this one. So this is the simple properties of reverse proxy. At the moment in the market, there are some different reverse proxies. Some of them are Nginx, Traffic, and so on. So in Kubernetes cluster, how we can deploy them? As you know, Kubernetes is a little complicated than the normal server. In normal server, yes, you can deploy one of these reverse proxy and bring it up and configure it and use that. But in Kubernetes, as you know, we are using YAML configuration. So how we can use that? Here, another concept comes to play. It's called Ingress controller. So what is Ingress controller? The core of Ingress controller consists of a containerized reverse proxy server, but instead of direct installation and management, we can do these things by Kubernetes style manifest. To implement reverse proxy in a Kubernetes cluster, we need Ingress controller. So if I want to use Nginx reverse proxy, I have to install Nginx Ingress controller in my Kubernetes cluster. Or if I want to use Traffic, I have to do the same for Traffic. So after install Ingress controller, we need to configure it. But we cannot going directly and make changes in Ingress controller. So another concept here that plays with Ingress controller, it's called Ingress. So when we speak about Ingress, always we have these things in our mind. So it means we have to deploy Ingress controller, and also to play this one we have to use Ingress. This one only install once in your cluster, then every time we wanted to access a new application, we can add configuration to Ingress. So Ingress resources and Ingress controller in Kubernetes allow you to manage HTTP access to your cluster. When deploying application to Kubernetes, an important consideration is how your application will be accessed by external user. The standard solution to this problem is Ingress. The good news here, the Kubernetes cluster that we are using at the moment is K3s. So K3s by default, when you install it, it has traffic ingress controller. If you don't like to use traffic, when you wanna install it, you can disable it, and after the cluster comes up, you can install manually by yourself Nginx ingress controller or the other one you want. But for the moment, this cluster has traffic ingress controller. So how we can see that? Just type kubectl get pods dash capital A. Here you will see all the pods in the system. You see here traffic pods. So let's type kubectl -n kubesystem. It means kubesystem namespace get all. Look here, traffic deployment, traffic replica set, traffic service, and traffic pods. So traffic ingress controller at the moment has been deployed by default and is in running status. Also, I have a bad news. The bad news is I don't want to use traffic in this cluster. I prefer to use Nginx ingress controller. So what we have to do? If I want to use Nginx ingress controller, I have to remove traffic from this cluster. The best way and easiest way to do that, rebuild the cluster by this flag -- disable traffic. With this one, our cluster will come up again without traffic ingress controller. Let's going to this way. So at first we need to destroy our cluster quickly. In Google, if you search how to uninstall K3s, you will find this page belong to official document of K3s. Just copy this one and go to terminal and run it. Quickly, your cluster will be gone. So we need to build our cluster with this flag disable traffic. Just by this command, at the end you see -- disable traffic. We run it again. So it will go and bring up a cluster without traffic. So the cluster came up successfully. You can type systemctl status k3s. Look here, it's running and ready to use it. Just clean a screen. It is better to rewrite the config file from the cluster to this path. So let's running, and if I type kubectl get nodes, you see we have a cluster with one node and it's ready to use it. Just type kubectl get pods. You see nothing is running. We have to install our application, services and everything. So if I switch to my configuration folder, cd to this one, all of you guys that watching this video have access to this configuration file. If you switch to this folder, you have access to all configuration. Just let's at first start deploy our configuration quickly and be ready to install Nginx Ingress controller and also Ingress, and see how we can access by Ingress to our application. All the configuration installed on cluster again, and now it's time to use Ingress. Before that, let's verify everything. Here is PHP my admin on this port, and also here our application in this node port. In Google, just search install Nginx Ingress controller on Kubernetes, and from the result and find the official website for Kubernetes and click on this link. Here you will see the official document for Ingress controllers. Here you will see Kubernetes as a project supports and maintains AWS, GCE and Nginx Ingress controller. So click on Nginx. So let's going down, and here you can click on getting start and you will go to official document for Ingress Nginx controller. Okay, let's going down, and here in the middle of the page you will see this link. Copy this one and back to our cluster, and in cluster just run this one. By this command you will see what will happen in your cluster. You see Ingress controller is in running status. So far so good. So Ingress controller deployed in your cluster. So let's Control C and clear a screen. Now it's the time to speak about Kubernetes Ingress. If we search on Google Kubernetes Ingress, from the result click on this one. Here this is all a story about Ingress. There are different type of Ingress. One of them is Ingress backend by a single service. If you have a single application and provide it by a service, you can use of this type. In next some minutes I will show you in action And also there is another one, it's called name-based virtual hosting. This is the one that we will use it in this project. Look here, this is the public IP of my cluster. I have an application that is running on this port and also another one on 8099 port. I did register a subdomain for it and I will use it, and also another subdomain with the same IP for the next one. Why I want to use of this type? Why we cannot the other one, this one? For example, the cluster IP slash, for example, application, and will reach to application on port 5000, or slash, for example, phpMyAdmin to access phpMyAdmin. Why I cannot use this one? For this type of ingress, as I told you some seconds ago, we need a domain. For having a free subdomain, you can use this website, docdns.org. Here you can log in there by your GitHub account, or as you see by your Twitter or another one. Just here I did by my GitLab account, and here the IP address of my cluster, and I did register this available subdomain. You have to search here. If your keyword is available, you can just add it here and use it. Here is the configuration that we can use it. Look here, I'm using this keyword host and added one of my subdomain here, and this is to reach which service? Application service on port 5000. And also by adding a copy of this one and change it to, for example, dbmanage.docdns, and change the service to reach phpMyAdmin service on this port, prepare it for Ingress. Finally, we need to do some changes. At the moment, our services are configured based on Node port. We need to change them to cluster IP for both services, and also prepare the YAML file and deploy it. I have another folder, it's called part 2 here. Let's switch inside that, and here we have some files. As you remember from some seconds ago, for deploy Ingress, we have to change application service from Node port to cluster IP for application, and the same for phpMyAdmin. Okay, so here cat application service. Here I remove Node port and change the type to cluster IP. It was like before. Let's show you quickly. Before it was like that. We had Node port and also type Node port. At the moment we change to this. Just remove this line and change this one to cluster IP. Clear screen. Just type kubectl apply -f this service. And also for phpMyAdmin, it will go and update the existing service. So kubectl get svc-oy. You see here this service and this service, both of them change to cluster IP. So far so good. So what we have to do now, we have to prepare Ingress YAML file and deploy it. I assume my application is like a single service. If I apply this application, kubectl apply -f and this guy. Okay, kubectl get Ingress. Yeah, it's deployed. And let's do kubectl describe Ingress and Ingress name. Let's clean a screen and rerun it again. If we type cluster IP / application, it should go to application-service on port 5000. If we type /php, it's supposed to going to this address. Let's do it in action. If I type this guy, cluster IP address and /app, let's see what will happen. Look here, it show our application like that. If, for example, I click on login, you see not found because this Ingress need to find this single service in backend but cannot find it. As you know, our application is configured of some services inside that. So if we need to access /login, it's not possible by this one. If now I type /php, you see, cannot display that. So this type of configuration is not suitable for us. So we need to use another configuration that I told you, it's called name-based virtual hosting. So here we need to register a domain. Clear a screen, cat, this one. Here is the configuration. If we type loginapp.docdns.org, it will go where? It will go and arrive to this service, application service on port 5000. If we type dbmanage.docdns.org, it will go and reach to this service, php myadmin-svc, on which port? On this port. Okay, let's kubectl apply -f and this guy. Okay, kubectl get Ingress, and you see here, this is the hosts and this is the address. Kubectl describe Ingress and Ingress name. Here you see, if we type this one, it will go to this service. If we type this one, it will go to php myadmin service. So far so good. Let's go into browser. In browser, type dbmanage.docdns.org. Look here, it show us php myadmin, and just type password, login to our php myadmin to show us configuration related to our database. If I type login app.docdns.org, look here, it will show us our application. If I click on this one, it's go to this one. You see here /login or sign up. It will go to register section. So at the moment you see how we can play by Ingress resource in Kubernetes cluster. If you remember, we spoke about deployment. For our application, instead of using directly a pod, we use a deployment, and the deployment help us if one of the pods for any reason going down, automatically will rebuild and be in service. Also, we can have some replicas of that application, and for any reason one of them is going down, the application work normally and there is no downtime on that. Let's have a look on that. kubectl get deployment. At the moment we have this deployment node application, and just it has one replicas. If for any reason this pod is going down, automatically will rebuild. Also, we can add more replicas to it to be completely sure if we get more traffic or if our application on one of the pods goes down, automatically the traffic will support by another replicas. Let's increase that one. Let's type kubectl get pods. Look here, we have this node application. If I do kubectl scale deployment, what's the name of our deployment? This is the name, -- replicas. Increase that to 3 replicas. Look here, deployment scaled. Just if I get pods, look here, at the moment we have 3 pods of our application, like this one. 3 copy of our application is running, and at the moment the incoming traffic will distribute between them equally. And as I told you, for any reason one of them is going down, the others continue to accept traffic with any issue or any downtime. If you see here, we have MySQL pod. At the moment, our database is running by only a single pod, not by deployment. So if for any reason this pod is going down, our database will be out of service. And as it is a pod, based on our configuration, it takes time to back, and maybe we lose some of our data. So maybe these questions come to your mind. Is there any way to using like deployment for MySQL pod? Yes, we can use, but not deployment. Why? Why we cannot use deployment for database? This is a good question. For application that we are using deployment, as I told you, the traffic distribute between them. It doesn't matter which pod reply the request. But for the database is different. If we have an application and application one write data to our database, if we have 2 or more replicas, only application can write on one of them. If it is supposed to write data in this database randomly each time, we will lose our data. Why? Because if once write here and another time write here, so from where the application now can retrieve data from which database. This is the main reason that we cannot using deployment for database. Let's go into terminal and show you another one. Here I split my terminal, and also I want to run this command. kubectl get pods -w will show you what will happen on time. Let's run it. At the moment, these pods are running here. Let's delete one of these nodes. For example, the first one. kubectl delete pod, this pod -- force. Look here, as you see, here it's terminated, but as it is a deployment, automatically rebuild that one. Look here, at first terminated this one. Look here, terminated, and after that rebuild another one. Container creating, and it's in running status. Here, if I run this one, you see again back. But as you know, before the delete action, this was the pod name, as you see, end with HC. But after the rebuild, the name changed. Look here, the pod's name changed and got a new name. So imagine we have a database and we define the database name in our application. if the database for any reason going down and back by deployment, it will get new name. So from where our application can find the new name. This is the second reason that we cannot use deployment for database. If we have two or more replicas of our database here, in each time only we can write on one of them. So the other replicas sync themselves with the main one. When the data write here, automatically copy of them will transfer here. So the data write here and a copy of them through the first or main database will transfer to the second one. And if we have more, for example, if we have a third one, it will get a copy from the second one. So the order here is very important. Here, another concept in Kubernetes comes to play. It's called a stateful set. With a stateful set, it is completely like deployment, but in a state of bringing up each pod with random name, it will bring up the first pod at first by index 0, and after that will bring up the second one by index 1, and so on. And also when we scale that, for example, if we have at first one and we wanted to scale it to 3 replicas, at first it will go and build the second one, and when it will be ready, it will go to the third one. So here we will learn about a stateful set. So until here, if you think about it, you will see each of these pods have separate storage. But in deployment, all of them have the same storage, but here is different. So we will talk about it quickly in action. In Google, if we search about Kubernetes stateful set, from the result, you can click on this one and it will redirect you to the main page of this subject on Kubernetes official website, and here is all the story about that. So how we can build a stateful set? If we going down, you can find a sample how to deploy it in your environment. One thing is very important. The service that you are going to use it in front of your stateful set pods should be headless service. This is a specific type of services. If you remember, also we did talk about cluster IP and node port, but here is one of the specific service that using for a stateful set. It's called headless service. You can search on internet and read about this one, but just to mention it here, in the service configuration, you define something like that. This key value cluster IP and the value equal to none. As you know, if we don't define any type of service, automatically it will be cluster IP. But if we define cluster IP equal none, it will be headless service. So let's go to terminal. At first, change our service to headless, and also using this configuration in our cluster. Let's do kubectl get pod. At the moment, we have one normal pod for MySQL and also deployment for node application, and also one pod for phpMyAdmin. Let's do kubectl get svc, and the same, one service for application, one service for MySQL, and one for phpMyAdmin. ls-latr and cat the configuration for MySQL service, cat MySQL service. Let's clean a screen and run it again. Look here, type is cluster IP, and here you see also MySQL service is cluster IP and has an IP address. At first, as we spoke a little earlier, we have to change our service to headless service. Just I copy it here in part 2. Look here, just I remove type cluster IP from this one and added cluster IP equal none. Nothing more. At first, let's remove this one, kubectl, delete service and this service. And here, kubectl apply -f MySQL service. Look here, it is created. If I type kubectl get svc, look here, the service created cluster IP, but none without IP. When it has no IP, it means it is headless service. I hope until here be clear. If you need more information about it, it is better to search on internet. Let's continue. Also, I have created this file, this file, db stateful set. Here is the configuration for a stateful set. Let's compare it with original file, cat db pod. Look here, image, the same image, all the configuration you see here, we added here, except one thing. As you remember from some seconds ago, each stateful set pod has a separate storage. It means we have to create separate PV, persistent volume, and persistent volume claim. For this one, in a state, we do it manually. In configuration, we have a template, volume claim templates. You see here, it will go, and for each stateful set, will create a separate PV and PVC. Let's clear here, kubectl get pod. At first, let's delete this pod, kubectl delete pod and this pod. So at the moment, we don't have any database in our environment. Kubectl get pods. Yeah, it's gone. But let's do it by a stateful set. Let's run it. Kubectl apply -f db -stateful set. Look here, it is created. Kubectl get pods. Look here, I started the first one by index 0. At the moment, we defined, as you see here, at the moment we have only one replicas. Vim db stateful set, just let's change it to number 3, for example. Just I want to show you the process of these stateful set pods. Let's save it. Here, kubectl get pods -w. Look here, kubectl apply this one. Look here, at first the number 1 it's going to be created. After that is created and running, the next one will be created. Look here, it is in running status. If I change it back to 1 replicas and apply it, look here, it will start from the last one terminating and also the second one. So if I do kubectl get pods, you see only the index 0 is in service. Let's go into browser, db.docdns. You see here is our database. If in our application. Just I do login and sign up, and let's create a user. Login and login. Look here, it's working. Let's back to terminal. Let's delete our database and see what will happen. kubectl delete pod. Which pod? This one, MySQL-STS. Look here, it's going and be terminated, and as soon as terminated, again, it will be created. Quickly, don't let us to going down. Let's back to our application and see if our data is exist or gone. Login. Look here, still the data is there. If I go to PHP my admin and refresh it, you see the data is exist. So using a stateful will be very useful for our application, but it is really complicated. At the moment, just we are using one pod in our stateful set. If we increase the number of our replicas, we have to do some changes, because we have to set one of them as the primary for writing and reading, and the others as only for reading. So this one needs a little configuration, and it's not in our presentation at the moment. And also, if you are interested in this subject, you can add your feedback in the comment section, and I can create a complete video about that one. A stateful set is done at the moment. Let's go into the next subject. In this section, I'm going to deploy our application and database by Helm. So before I start, let's remove all the configuration. Just if I type ls-latr, all the configuration here, just type kubectl delete -f and dot. You see all the configuration that are deployed here done. Let's go into part 2 folder and run the same command here. You see the ones that are in service like Ingress and stateful set deleted. If I type kubectl get pods, no pods, svc no service, this is the default service of the Kubernetes cluster, and also get deployment, nothing. So all gone. Let's go in and create the Helm charts for our 3-tier application. To using Helm in our project, we need to create Helm chart. So what is Helm charts? To be honest with you, in separate video, I did already extensively speak about Helm and how we can create a Helm chart and how we can use them and how can create a Helm package and so on. Here, I don't like to speak more about it, just I pinned the link of this tutorial about this video. Also, I will add it in the description, and you can follow it and learn about Helm and how we can use it. Just here in summary, I tell you, if we want to create a Helm chart, just type Helm, create, give it a name, for example, test1, and enter. You see, test1, it will go and create a Helm chart with name test1 for you. If I type 3 test1, you see in this chart test1, you will see some files. If I do switch inside test1, you will see a folder called template, cd template. Here you see all the YAML configuration that we're gonna use for example, for MySQL, for application or PHP MyAdmin. will be here. As we are creating 3-tier application, we need to create 3 Helm chart, one for MySQL, second one for application, and the last one for PHP my admin. I did create those charts. Let's switch back, and in part 2 folder just type ls-latr. Here you see I have created 3 charts, one for PHP one for application, and one for MySQL. Let's switch inside MySQL, and in template folder I did remove the default YAML from there and copy there my YAML files. Let's type ls-latr. You see one for a stateful set, one for service, another one for config map. As you know, this is for creating table and records, and the last one for the database secret. In application chart templates, and here you see app deployment, config map, secret, and secret for registry for pulling the image, and also one for service and for Ingress. And also I did the same for PHP my admin. Let's switch to part 2 folder, and here just ls-latr and just type Helm, install, give it a name, for example login application, and the chart path. Enter. You see login application deployed. And let's do the same for MySQL and for PHP my admin. For MySQL, just type MySQL, every name you want, and for example, and also the path, also MySQL deployed, and for PHP my admin, and the path of its chart, and this one also deployed. Let's clear a screen. Just type kubectl get pods. Look here, MySQL, also application and PHP is running, and also get svc. All the services are up and running, and the same for Ingress. You see, we could bring up our 3-tier application by Helm. Here, if I type Helm list, it will show us the Helm charts that are in service. To uninstall the Helm chart, just type Helm uninstall, and the name, for example, login application, quickly gone. And for example, for PHP my admin, also it's gone quickly, and the same for MySQL. You see, it's done quickly. So far so good. I think everything is enough for this presentation. If you wanted to play this application by CICD, I suggest you do it, because I have 3 videos about how to use CICD to deploy an application on Kubernetes cluster. So I will add the link of them in description, and you can watch them and by yourself try to deploy this application by CICD. If you find problem to deploy it, please comment, and I will take care of that in separate video. Thank you so much for watching my video, and see you in another's.